Okay, let's solve this LeetCode data problem. We're given an integer array nums and an integer k. We have to find the maximum subarray sum of all subarrays of nums that meet the following conditions. We have two conditions here. The length of the subarray is k, and all elements of the subarray are distinct. So out of such subarrays, of all subarrays, we have to find the one with the maximum subarray sum. If there is not one, so then we return 0. Let's look at this example here. We have a subarray of size 3 starting at the first index. It's 1, 5, 4. All elements are distinct. Let's call this subarray distinct subarray. So this subarray is distinct subarray. We have a sum of 10. Then we move starting from the second index. We have 5, 4, 2. This subarray is also distinct and has a sum of 11. Then we have 4 to 9. This is also distinct. We have a sum of 15. And we have 2, 9, and 9. This is not a distinct subarray. We have three, although we have 3 elements, the 2 of them, 9 and 9, they're same. And we have 9 and 9 and 9. This is our final one. And this is also not distinct, so it does not meet the condition given above. So we only have 1, 4, 1, 5, 4, 5, 4, 2, and 4, 2, 9. Out of this, 4, 2, 9 has the maximum subarray sum, which is 15. Hence, the answer is 15. Now, let's move on to the explanation. Now, let's get to the explanation. One way to solve this problem is to brute force it. We can start at index 0, and we can grab the first k elements, in this case first 3 elements, and check if this element, that we can keep a frequency array and check if this element, if the subarray contains distinct elements. If this is the case, we could update the answer. In this case, for example, we have 1 and 1 and 1. And this is not a distinct subarray, and we can ignore it. And then we start the second subarray from index 1, and we grab the first 3 elements again. So we have 1, 1, 7. This is also not a valid subarray. Then we start at index 2. We grab the first 3 elements. We have 1, 7, and 8. This is valid, and the sum is 16. By valid, I mean this subarray meets the conditions. The condition says that all element must be distinct. So we have 1, 7, 8. The sum is 16. We update our sum. We have seen 16 first. Then we start our final subarray at index 3, and then we have 7, 8, and 9. These are also, this subarray is also distinct, and the sum is 24. Now we update our sum to 24. So 24 is the answer to this problem. So the time complexity of this problem would be of n times k. So I'm ignoring the frequency array. It wouldn't cost much time. So then we have n times k. So given the constraint, this would give probably TLE, because n was, I guess, 10 to the 5th, and the k varies between 1 and n. It's somewhere here. So this would be roughly actually of n squared, similar to of n squared. So this would not work. Okay, now let's focus on optimizing this. When we have a subarray here, then we found that this is not valid. Then we basically shift this the subarray, this window. The size is always k. The window size is always k. So that basically we kind of shift this to the right. So then we start from here and here. Now what happened is that we excluded one element from the previous window and included one element to the current window. So there is too little that changed. So we have only 1 that goes out of this window and a 7 that comes into this window. The remaining k-1 elements are the same. We just ignore this one. You can see this one is included in this subarray is also included in this subarray. So what we can do is not to overdo this part here, because this part is overlapping in both of this window. Instead, we can just deal with this changing elements. We have a new incoming value and an outgoing value. There is a way to deal with them. So that is the basic promise of sliding window. We have generally two types of sliding window. One that change its size freely. Basically, you have a window, like let's say this way, and it has to satisfy some condition. If it is valid, or it could be valid or invalid based on the conditions of the current window, we either shrink it from left, or we either expand it, grow this window from right. So we expand this from this part or shrink it from this part, and it could be of any size. This usually occurs in problems where it asks the smallest subarray or largest subarray with some conditions. So when you have a subarray that satisfies some condition, based on this, you say, okay, let's grow the window. If it asks for example, the largest subarray or smallest subarray, then we can shrink the window if it is valid, if it is possible. Otherwise, we don't do that. And the second type of window is of fixed size, like this one. We have a window of k size 3 in this case, and this window, and we asked to find the largest sum or the smallest sum or smallest something within this window of size k. In this case, this is actually much easier than a freely shrinking window or growing window, because in this case we at least something that always same. So this window always slides to the right and with a fixed size. So in this case, the size does not change, and we can easily slide the window one element to the right and exclude one element from the left. So in our case, we move this one to the right. Now, previously we have the count. Let's count the number of elements in the first window. We have 3 ones. This shows the number of elements. 3 ones. Okay, what is the number of distinct elements in the first subarray? The number of distinct element, let's call it x. The number of distinct elements is 0. We do not have any. Then we move to the right, the window. So then now we get rid of one of these ones here. So its frequency is not 3 now, it's 2. But still we have 2 of them. So we say that an element is distinct if it appears only once, if its frequency is exactly 1. So in this case, it's 2. So it's still not distinct. 1 is still not distinct. Now we have 7. The count of 7, let me write it here, is 1. Previously it was 0. We did not have 7. Now it's 1. So now we can increase this. X becomes 1. We have one distinct element. It's 7. Then we move this window 1 to the right again. Now we get rid of one of these ones, so its frequency comes down to 1. Now, since we have one of this element, it must be distinct. It's distinct. So we increase this to 2. And we also included 8. The count of 8 now is 1. We didn't previously had 8, and now we have 1 of it. So we have a count of 3 now. The 7 does not change because it is the same element in both of in this one and in this window. 1 and 7 this 1 and 1 does not change. We only excluded this one and included this 8, and according to that we decrease the count of 1, frequency of 1, and increase the frequency of 8. So the frequency of 1 became 1, and also frequency of 8 became 1. So we get 2 new distinct elements. Now the number of distinct elements is 3, which is equal to the k. This means that all elements of this subarray are distinct. So we can now take the sum of the subarray. Also, remember, we can keep track of the sum just like we keep track of this frequency. We can have the sum of the first subarray, which was 3, and then when we excluded 1, we can exclude the 1. Basically, we can subtract 1 from the sum. And when we included 7, we can add 7 to the sum. So we can also keep track of the sum just like we do the frequency. So we don't need to reiterate to get the sum of the current subarray. So we have 1, 7, 8, 16. So then we update our answer. So then we move on to the last one, which is 7, 8, and 9. Now we included 1. The frequency of 1 now becomes 0. We do not have this element anymore. So previously it was distinct. Now we do not have it. So the number of distinct element, x, is now 2. Now we included 9. We did not have 9 previously. Now we have 1 of this element. So then we have 3 distinct values again. So we found the sum. The sum is 24, and we update the answer. This is basically the sliding window of fixed size. Now let's go to the code. Okay, here's the code. Now we said that we can keep track of the sum just like we do the frequency. Now this is a frequency array. We're going to keep track of the count of every element. First, in this case, or with most of the sliding window problems, first we have to fix some valid subarray. We fixed, it could be valid or invalid. In this case, we just fix a subarray of size k. This is the first subarray. Starting from the index 0, we go up to k. So k minus 1, we start there. And we find the sum, and we get the frequency. And then we have the count here, down here, the number of distinct elements in the current window. We go through the map, and we do this once, only once. We go through the map and find the one with frequency 1. These elements appear once, so they're distinct. If after that the number of distinct elements is equal to k, then we update our answer with the sum of the current window. Then starting from the next index, index 1, we're going to go up to m minus k, and we exclude nums I minus 1. Basically, previously our window started at index I minus 1. So index, basically in this case 0. Now it starts at 1. So we have to exclude the I minus 1. We decrease the frequency of the excluded leftmost value. Then if the frequency, previously there could be more of this element. Let's say there were two of this element. We now excluded one of them, and now it has there is only one element. There's only one frequency. This frequency is 1. So when frequency is 1, this is a distinct element. Otherwise, if it becomes 0, previously it was distinct because its frequency was 1. Now we do not have it, so we have to get rid of this element, so it's not distinct anymore. So we decrease the number of distinct elements. We also get rid of this element, the value of this element, from our sum. We just subtract it from the sum. Now we have include the rightmost element, the one that comes to the array, the current window. And we increase this frequency of this element. And if frequency of this element becomes 1, basically we did not have it before, then we have a new distinct element. Otherwise it becomes 2, not 3. So because we have 2 of this, and we increased it become 3 or it become more, it becomes, for example, 5, then previously it was 4. It wasn't distinct anyway. But it becomes 2, it was previously 1. So it was distinct previously. So now it becomes not distinct. So we have to decrease the number of distinct elements. Now after that, we're done with dealing with the current window. This is basically exclude the leftmost and include the rightmost. And then we have the sum. We have to also include the value of this sum in the value of nums_i, the rightmost value in our sum. If the count is equal to k, if the number of distinct element of the current subarray is equal to the size of the subarray, then all elements are distinct. Then we update the answer, and at the end we return the answer. This was a simple sliding window, and sometimes you got this kind of questions. And basically, when it's most of the time when the window size is fixed, it asks for the maximum number of something, or the maximum sum, or a minimum sum, or something like that. In other cases where the window size shrinks, they usually ask for the longest or shortest subarray that satisfies some conditions. See you in the next videos.